Good morning, everyone. Today we'll be starting with our new chapter, that is symmetry, reflection, and rotation. So, this is chapter 16 from your book, and in this chapter, what we will be discussing is all about introduction, that means about symmetry, then the introduction about the line symmetry, then what is point symmetry, then symmetry of some of the figures also we will be discussing, then reflection, and the next extra topic that we are going to discuss is rotation. So in the upcoming classes we will be discussing about all these contents, and after finishing these contents we will be moving to the next topic, which is rotational symmetry. So now let us begin with our topic, that is symmetry. Okay, so let us start with.
In our day-to-day life, we see many figures which have very harmonious proportionality and balance. These figures possess very precise and well-defined sense of balance in their shape. Some such figures can be observed in nature, architecture, designing, road signs, etc. We usually say that these figures are symmetrical, and the criterion is called symmetry.
Okay, so now we have already seen many examples of the figures which are symmetry. So now what is symmetry? Symmetry is basically the property which is exhibited or which is possessed by the pictures or the objects, such that if we fold them along a particular line or if we turn them around a point, they look exactly similar. Alright, so here let us have some examples. So this page is in the form of a rectangle. Okay, now if I fold it along this line, along the central line, like this, if I fold it along the central line, let me fold it. So this line along which I am folding, so if I fold it along this line, can you see the margin along which I fold it? Okay. Now if we are folding this page along this line, you can see the two halves of this rectangle is exactly overlapping. Okay. So if I reopen it, we can see the first half and the other half. So when we have folded these two halves along this line, we see that these two halves are completely overlapping each other. So thus we say that these two halves are symmetrical or identical to each other. So here we can have a beautiful flower, okay, and can you see if I divide this flower from this mid part, so we get exactly the same figure, or if I overlap it or if I fold it along this middle part, what we will see? We will see that it is exactly identical. Let us see, we have a flower and we have divided it from the mid, and if we again rejoin, we exactly get the same picture of the flower. Alright? So we can say that the two halves of this flower is identical. Here again, if I divide the Taj Mahal from the mid and if I rejoin it, we get the exactly same parts of both the sides. And can you see this beautiful butterfly? If I divide this butterfly from this midpoint, the two halves is exactly symmetrical. Or if we overlap it, we will get the identical figure. So this case, we see that these pictures are symmetrical in shape, or the two parts are said to be symmetrical. So basically the two figures or the pictures are said to be symmetrical if they are divided or if they are folded from a common point and they exactly overlap each other. The two parts get exactly overlapped to each other. So in that case we say that the two parts are symmetrical in shape. Now, after understanding the concept of symmetrical, let us start with lines of symmetry. Okay, so you can see in different figures we have different line of symmetry. Okay, like in Taj Mahal, if I divide it from this midpoint, so this red dot indicates the line of symmetry. The scar, if I divide it with this midpoint, it shows the line of symmetry. Okay, so this is the line of symmetry. All the figures basically we can see necklace, the point. So the figures with evenly balanced proportions are called symmetrical figures. And here we have different shapes which shows that they are symmetrical. Here we have some alphabets which shows that they are symmetrical in shapes. Alright, it shows there that they are symmetrical. And the line along which we fold or the line along which they divide, this line is said to be the line of symmetry. So here we can see this horizontal line is the line of symmetry, or it is also said as axis of symmetry. So finally, what is the conclusion? That the line of symmetry is the line where the shape can be folded such that the two halves look like the mirror image. It can be horizontal or a vertical in shape. So this was all about line of symmetry. So if I discuss the line of symmetry in the concept which we have taken, let it be the figure. So what we can say, when I folded this particular paper, so we get two halves. So can you see the line along which I folded it? So this line is said to be the line of symmetry. This line is said to be the line of symmetry. Either I fold it in this way by the vertical line of symmetry, or I fold it along the horizontal line of symmetry. We get exactly the two shape. So this was all about lines of symmetry. So here, if I ask you to draw a line of symmetry in a given figure, so the given figure is a parallelogram, and if I ask you to draw a line of symmetry, so will you be able to draw it? No. A parallelogram has no line of symmetry. So we can say that a figure may have or may not have a line of symmetry. It's not mandatory that all the figures, if I fold it along a particular line or along a line, we will get a symmetrical figure. So there is a possibility that the given figure may have or may not have. So we will be discussing about the line of symmetry, or how the shapes or how the sizes or how the figure is symmetrical in different shapes. So we have learned that a parallelogram doesn't have any line of symmetry. But can we say that it is not symmetrical? See, though the parallelogram doesn't have any line of symmetry, but then also the figure is symmetrical about a point. Here, let us take a central point O and a P point here. And let the down point and we draw one vertical line, and let us take the down point as P dash. Now here what we will do? We will measure the distance of OP and OP dash. Now let us take some more pair of such lines. So on taking more pairs, what we will find that all the points which we take from equidistance, so which is equidistance from O, like Q, Q dash, R, R dash, S and S dash, we will see that all the points have the same distance. Like OP will be equal to OP dash, OQ will be equal to OQ dash, and so on. Even if in the case of diagonal also, we see that the diagonals are equal from point O. So we say that whole figure is symmetrical about point O, and this is known as point of symmetry. That means about this central point which we call O, this parallelogram is symmetrical. Okay, so even though this parallelogram doesn't have any line of symmetry, but then also this parallelogram is symmetrical about a central point, and the point along which or about which the figure is symmetrical, this point is known as point of symmetry. So I hope this concept is clear. Tomorrow we will begin with few more new topics of the same chapter, that is symmetrical. Till then, keep on watching the video, try to understand the concept, and if in case any doubt, you may refer or you may ask your particular subject teacher. Thank you for watching the video.